I believe I've started my recording here, so we will work on this. It's kind of a new thing. So today we're working on Module 5, and Module 5 is very algebraically intense and has the added feature of not only doing algebra with factoring, but then actually asking you to go back to fractions and be able to deal with fractions. So you add those things together, and in math, you know, one thing that's difficult and another thing that's difficult, 1 + 1 turns out to be like 10, right? It doesn't really go 1 + 1 is 2. It ups the difficulty level quite significantly. So we're going to look at some of the rudimentary things of factoring. That could be an entire hour session, but I'm going to try to just show you the basics, and then you guys can direct me if you need more help. We'll talk a little bit about fractions, and then we'll get into rational expression questions. I will give you an opportunity to let me know which ones on the Module 5 assignment are, you know, looking at you if you have some comments there, and then I can work that in closer to the end of our time. Okay, so for factoring, when I go back into grade 10 and 11 and I'm teaching and or reminding students about factoring, the way that I get them to remember it is to count the number of terms, and then that sort of shakes out and helps you with your process. So when we factor, first of all, we do have to try to common factor. I'll show questions on each type of factoring I'm going to talk about. There are 4 types of factoring you are responsible for knowing how to do by the time you're in 30-2. Okay, common factoring you try at the start always. You always start with this. And then after that, you count the number of terms. And then based on the number of terms, there are different strategies to actually try to break down the algebra expression into factors. Two-termed expressions, the process is called doing it as a difference of squares. These ones, once you recognize them, are actually pretty nice, quote unquote. Okay, so they look like this: x squared minus 4. And so we just take the square root of the x as the first term in both brackets, the square root of the 4 as the second term in both brackets, and a minus and a plus. So hopefully you remember those ones from previous courses where it's just 2 terms. We take the square roots, plus, minus, we're done. They usually are pretty nice. And that's the only type of factoring in high school you're responsible for knowing how to do for 2 terms. We do learn in upcoming courses, like kind of university level, difference of cubes. And that used to be down in the high school curriculum. They're not all that hard. I think they've decided there's only so much they want your poor brains to be exposed to. And so they've just taken that out of the curriculum right now. Okay, most of our time is set up with 3 terms, which are called trinomials, just if you want that terminology there. Now, having not been your high school teacher for grade 10 and grade 11, the terminology of how I talk about this might be a little bit different, and there are different strategies. So it's going to be interesting to help you. You guys might have to come onto the chat bubble and help me out. So I break trinomials down into 2 types. I call them trinomial short. And if you're taking some notes, I'm going to leave a little gap of a couple of lines, and then trinomial long, or decomposition questions. Now, my experience is that most of us teachers at the high school level teach trinomial short fairly consistently the same. And then trinomial long, I know of 3 different ways. And I don't know if we're going to have time to break that all out, because that, again, could consume our time. So we'll see how that goes. Trinomial short questions are where we have a 1x squared term. There's a 1 in front of the x squared. And then we have some other terms after. But the big thing is that we have a 1x squared. Okay. And then we do a product sum chart. Okay, so in this little chart, that's all I'm going to say. I'm going to break it out and do a question in a second on trinomial short and show you how it looks. A trinomial long question is where we have a number in front of the x squared that we can't common factor out, like that 2 has to stay there. And then I'm going to do this decomposition method, and I'll show you what that looks like. And then we will pause. I'll pause the recording, and then we'll chat about whether any of this for trinomial long looks like what you were presented with, or if you want me to diverge a little bit. Okay, so that's kind of your factoring chart, should we say. Now let's do a trinomial short and a trinomial long. Okay, so this is a question that would qualify as a trinomial short. We're going to factor x squared minus 1x minus 12. Okay, and the reason we know it's a trinomial short is because there's no number in front of the x squared. We're assuming there's a 1 there. Now, hopefully you've seen this. I'm pretty sure this is probably the method that you've been shown, is that you use a product sum chart. The product is term 3, T3. So this is term 1, term 2, term 3. Just counted them. The T's are just indicating terms. So we're trying to find a product of minus 12. And then the sum number is going to come from the second term, term 2. And that is minus 1. Now, when I do these questions, I ignore negatives to start because they're just something that clouds the whole thing. I do my factoring, and then I look back at the negatives and try to figure out how to put them in. So what we're tasked with doing is writing down all the factors of 12. And the way that I show students to do that is just start by dividing by 1, 1 times 12. Again, I'm ignoring the negative for the moment. And then divide by 2, 2 times 6. Then divide by 3, 3 times 4. And then divide by 4. But once we get to that back number, we can stop factoring because we've got the set of factors. That is all the factors that multiply 12. 1 times 12, 2 times 6, 3 times 4. Now we have to turn our attention to the negatives. We can't ignore them forever. It's nice to ignore them, but we can't do it forever. So then we have to kind of sit and ponder and go, okay, they've got to multiply to a negative, which means one of them's got to be negative, one of them's got to be positive. And they've got to add to a negative number. So that means that the larger number has to be negative. Now I'll say it one more time for anyone that's, you guys that are here and those that might watch the recording. We are looking for a negative product. So one of them has to be negative. And our sum is also negative, which means the larger number has to be negative. So what that does for us, and I'll change my pen color, is that means I'm going to be tucking the negatives in to the back numbers because they're bigger than the front numbers. And now to find my numbers in the second column, I'm going to add them. So 1 plus minus 12 is minus 11. That one doesn't work. I'm looking for minus 1. 2 plus minus 6 is minus 4. That doesn't work. I'm looking for minus 1. 3 plus minus 4 is minus 1. We have success. Okay, of course it had to be the last one, but that's okay. It gives me a little bit more explanation time for this question. Then all we do to finish is we write our answers. So we know that our goal is to get two brackets, get factors. The first term in each bracket is x, and then we use these numbers here. So it's x plus 3 and x minus 4. And there's the final answer. Okay. Now I'm going to pause the recording. Okay, super. Well, we're going to go into trinomial long. As I mentioned earlier, this is where, depending on what school you're at, what your teacher likes to do, you may have been presented with a number of ways. There's lots of really good ways. Like, don't hear me saying that the way that you were shown is not valid and fantastic. I just have my bent of how I like to do things. And so that's what I'm going to show you is the trinomial decomposition method. Okay, so. So the question we're going to look at is going to be 2x squared plus 5x minus 3. So it really does look very, very similar to the trinomial short. The identifying feature about it being a trinomial decomposition question is this number right here. I can't common factor 2 out of 5 and 3, so it's stuck sitting there. And so we know that it's a trinomial decomposition question. Now, the start of how I do it is very, very similar. We do a product sum chart, and then we have to go and digress and do the decomposition part. So I write my product sum. The product this time is term 1 multiplied by term 3. We have to take into account that number out front. So our product is going to be -6, 2 times -3. Okay. And the sum is term 2. That does not change from the process above. So our sum is 5. And sometimes our numbers just pop right out at us. I didn't make anything too hard here as our first decomposition question. And quite frankly, this is about as hard as it gets in 30-2, because as soon as they put anything tougher, it already is pretty tough material. They try not to overwhelm you with too hard a factoring. So we write down all our factors of -6. Again, I ignore the negative and I go back in. So I get 1 times 6, 2 times 3. And again, as soon as I get to 3, I know that I've got all my factors. Now this time I have a negative product, which means one of our numbers is negative, but I have a positive sum, which means that our larger number is going to be the positive number. So this time the negatives are going to go on the negative, on the smaller numbers in front. And then I add, and look, boom, already I get my answer. So I don't even have to go to the second one, right? -1 plus 6 is 5. In fact, if I'm trying to keep with the notes of what I have right above, I can go -1 plus 6 equals 5. Okay, beautiful. So this is where we need to be putting our attention. Now here's where the decomposition part comes. We take these two numbers and we break down the middle term into those numbers. So this is what it looks like. 2x squared sits there, plus 1x. Oops, -1x, sorry about that. Got the signs right, -1x plus 6x minus 3. We decompose 5x into -1x plus 6x. It's a true statement, -1 plus 6 is 5. And then what we do is we do 2 sets of common factors. So I always kind of explain to students, pretend you're breaking the question apart right here. Okay, and we're only going to focus our attention on the first 2 terms and then the last 2 terms and do some common factoring. So if we focus in, and I can do some nice color coding on the ones that are underlined by red, we have to figure out what common factors out of both of them. And there's no common factor number wise, but there is a common factor of x. So I can take an x out here, open a bracket up, and I would be left with 2x minus 1, taking an x out of both places, common factoring. Then I go to the back 2 terms. Again, I'll just kind of change my pen color to the ones that are yellow, and I common factor those. Here I can take a 3 out. And when I divide those two terms by 3, I get 2x minus 1. Now, the key to these is I have to come out with the same bracket here. If I don't, I got to go back to the drawing board and figure out what I've done wrong. Okay. And that sometimes is a process in itself, but those have to be the same. And then what we do is we do one more set of common factors. The 2x minus 1 comes out front. And then the leftover terms at the x plus 3 go in the back bracket. And either way, I don't care which order, but this, here, I'll get one more color. The x from here goes down into here. And 3 from here goes down into here. And there's our factored answer. Now, the nice thing about factoring, if I can say anything nice about this, I love algebra, but that's not to say that I think all my students do. But the nice thing about this is you can always just do FOIL to check your answer. If anything is good about this, at least that is, okay? Now, I'm again just going to pause the recording to chat with the students that are here. Okay, so now what we're going to do is we're going to just remind students about fraction rules. Okay, so fraction rules, you probably, let me think, you definitely did them in junior high. If any of you have come from 20-1, you will have done rational expressions, so you will have done some fraction rules. If you came through the 10 common 20-2 route, you might have done a little bit in 10 common, but it might have been a while since you've done fractions. So let's bonus up and remind us of how to do it. Okay, so I'm going to start with multiplying and dividing, because believe it or not, it's actually easier than adding and subtracting. So for multiplying and dividing, generally, so they're very similar. I'm going to start talking about multiplying because there's a little thing we have to worry about dividing. All you do with multiplying is you try to reduce top to bottom. And then you multiply the numerator by the numerator and the denominator by the denominator. Okay, and again, I'll break it out. We'll look at a question. And the only difference between multiplying and dividing is you have to invert the second fraction and then do your multiplication rules. Okay, so you invert and multiply. Now, I know that some kids have told me when I've taught 10 Common, they've been told to kiss and flip. It's kind of a cute little way of remembering it. So you're flipping the second expression and then you're doing your multiplication. Okay. Now, to get into a question like this in terms of fractions, we won't do it with rational expressions yet. I'll throw a question up and we'll just do a dividing question here. So give me a second just to put a question on the board. Okay, so let's say we have something like 4/9 divided by 2/3. Just to remind you of how to do multiplication and division. So I gave a division because it gives us the kiss and flip or the invert multiply. So our first step would be to leave the 4/9 sitting there and multiply by the reciprocal, 3/2. Okay. Now, what I mean by reducing top and bottom, and this is kind of crucial for when we get into the rational expression part, if we see something on the top and the bottom that have a common factor, then we want to divide the top and the bottom by the common factor. So we see that 2 can be divided by 2 and become a 1, and 4 can be divided by a 2 and become 2. So we're going to divide the top and bottom by 2. That's what we just did there. And then the 3 and the 9, so the 3 can divide by 3 and become 1. And the 9 can be divided by 3 and become 3. So that's the reducing part. And it will be really crucial that when we do our rational expressions, we're careful about that. And so then we get the answer here of 2/3. Okay. So a little note here, no common denominator work when you're multiplying and dividing. I'm going to put that in the green here, no common denominator. So just be cautious that you're not doing any common denominator work here. Okay, now let's talk about adding and subtracting. So adding and subtracting, we can use just one set of rules across the board. Basically, what we have to do is we have to make a common denominator. And then we have to find new numerators. And then we add or subtract the numerators. And we leave the denominators the same. Okay, give me 1 sec. Okay, so let's look at a question here. Let's do, let me think here. I don't know. I don't need to make it difficult at all. We just need to review this. So 1/2 plus 2/3. Let's just say that's the question. Don't need to make it difficult. So we need to find a common denominator. Oftentimes finding the common denominator is just multiplying the two denominators together. So in this case, we've got a 2, we've got a 3. We need it to be common as 6. So we're going to make our new denominator 6 for both of them. And then again, because I've got the ability to change my pen color, I have multiplied this by 3. So I multiply that by 3. And then that gives me my new numerator of 3, 1 times 3, okay? And then we do the same thing for the next one, where we're multiplying the 3 by a 2 this time. So we multiply this by a 2, kind of like this color coding. And so this becomes 4, because we had a 2 initially, 2 times 2 is 4. That's making a common denominator and finding our new numerators. Then we add or subtract the numerators and leave the denominators the same. And so then 3 plus 4 is 7 over 6. And we can leave it like that. In rational expressions, mixed numbers don't come up. So we might as well just use that. Okay. Okay, so now we're ready to rock and roll and do some take all this work that we've done on factoring and fractions and throw it all together and do rational expressions. Okay, so the first question, it says simplify and state non-permissible values. So NPVs, we haven't talked about that yet in class, but we'll get at it right now. These are non-permissible values. Okay. Now let's have a look at this question. There's one thing that I personally don't like on the top of it. So I am giving you my preference of things. I don't like when the order's wrong. It bugs me. It discombobulates me. So I always, and I do a lot of math, I always put my squared term first. So I would start this question, even though it really does not change the intent of the question at all. I will do that to start. Okay, because we always start with squared terms. Now, the steps for simplifying is that we want to try to factor. Then we want to state the non-permissible values, which again, I've alluded to, but I haven't really talked about. And then we want to simplify. That's sort of the order of the day. So remember, back to our factoring chart that we had at the beginning, we're going to try to common factor. And then we're going to see if there's any other types of factoring that could come up. So we'll just do it step by step. So I see some common factoring on the top. I see that I have an x in both terms. So we could take an x out and be left with 2x plus 3. I also see in the bottom that I have an x in both terms, and I take it out and I get an x minus 6. Now, to fully check our factoring, we count the number of terms left in our brackets. 2x plus 3, we have 2 terms. But for it to qualify as a difference of squares, we could have squares, and we don't have squares. So there's no more factoring to be done with 2x plus 3. Go down to x minus 6. Same thing, we've got 2 terms, but we have no squared terms. So now we're assured we're done the factoring. Now, before we do any simplification, we want to state non-permissible values. So I need to talk about what those are. Non-permissible values stem from the fact we cannot divide by 0. We all know at this point in our math career and in life in general, we cannot divide by 0. So we have to lay out for the reader that all our work will be valid as long as the value of x is not non-permissible. That will make the bottom a 0. So here's what we do. We say that x times x minus 6, that's what we're going to be looking at. X cannot equal 0. Otherwise, all our math is actually incorrect because we would be dividing by 0. And x minus 6 cannot equal 0, or doing a little bit of solving by adding 6 to both sides. X cannot equal 6. So when we're done doing all our simplification, we tuck the non-permissible values at the end and say, here's our answer, as long as x are not these values. X can be 2, x can be 1, x can be a half, x can be any other number on the planet, except in this question, it can't be 0 and it can't be 6. Okay. Now we go up and we actually simplify, and the only thing we're able to do is cancel an x on the top and an x on the bottom. And so our final answer here is 2x plus 3 over x minus 6 And then we just put however x cannot equal 0 or 6. Okay, so we have to tuck that in at the back. So we have now looked at how we put factoring into a little bit of fraction work, and we add in non-permissible values. So this question is a lesson quiz question from Module 5, Lesson 1 quiz. So anyone that's watching the recording or here can go and find that question and follow this along as a guide. Okay, so here's our final answer. And I just want to highlight some of the things you're not allowed to do to kind of point out, like, try not to get caught on this. We only can divide out items that are fully multiplied by other terms. So I sometimes will see, and please note that what I'm doing is wrong. Okay, this is not how to do it. I'm going to erase these. I'll have students go, oh, well, ooh, look at X on top, X on bottom, boom, done, punt them out. And then I'll say, oh, well, look at 3 divides by 3 and gives me a 1, and this divides by 3 and gives me a 2. You can't do any of those things because you got addition and subtraction numbers there. So one moment. Okay, so you have to be really cautious about that. So as you're working through these, I'll just fix my answer here. If you're not sure, certainly be taking some screenshots or some pictures of what you're working on and send them to me so I can help you sort out when you're allowed to cancel and when you're not allowed to cancel. You have to have basically either a bracket that you're fully canceling or an expression outside the bracket. That's how you're going to know that you're able to cancel. Okay, so let me go and find another question from a quiz that we can mess around with. Okay, that one's not too bad. That one's not too bad. Okay, let me go to the second quiz. And again, students that are here, if you guys have any in particular, you could just type me a little message and I can grab them. I'm just going to try to pick a question here and there from the lesson quizzes that are decent. Okay, that's not a bad one. That's not a bad one. Okay, well, I think I'll just maybe do that first one. Okay, all right. So yeah, simplifying, and maybe I'll try to find some harder simplifying ones where they're kind of ugly. Okay, so I've got a couple more in mind that we can do. Let me just note them down here before I change my screen. Okay, this is going to be a division question, and then we're going to do a simplification question to work on. All right, so this one, I think there's enough room and it's fairly clear. So it's going to be divide and simplify fully. And one thing to note, even if it doesn't say to state non-permissible values, please state non-permissible values. Okay. Perfect. A little, we'll go to that one on the assignment that was just pointed out to me. Okay, so here's the question. It's similar to one on Module 5, Lesson 2 quiz. Not quite exactly the same, but very similar. It says x minus 3 over 5 divided by 5x. No, I think I'm going to have to, 1 second. I don't think I copied it right, but anyway, I'm going to make one up on my own then over 2x. Let's say that's the question. That's a good question. Okay, so x minus 3 over 5 divided by 5x minus 15 over 2x. So far, not really hard factoring. I'm not trying to throw too tough a factoring in, just trying to slowly put everything together for us. So the first thing I would do with a division question is I would flip the second one upside down. I wouldn't do the factoring yet. Personally, I would just do this. X minus 3 over 5 multiplied by, I'm going to use a time sign because we got x's, 2x over 5x minus 15. Okay, that's our first step. Now we're going to find non-permissible values. Okay. Oh, actually, now we're going to factor. So here, if we want the steps, I can just, okay. So step 1 for division, invert and multiply. And then the steps from simplification are exactly the same. We're going to factor. We're going to state non-permissible values. And then we're going to simplify. Okay. So factoring, the only thing I can see to factor is the 5x minus the 15. But I'm going to give you a little suggestion. When you have a binomial like x minus 3 and there's nothing to factor, you might want to put it in brackets just to show you that, like, maybe put a 1 out front to indicate to you that they sort of are, they're together. They cannot be separated. Okay. And then over the 5, nothing there. Multiplied by the 2x, nothing there. And down here, we're going to be able to take a 5 out and get x minus 3. Okay. All right. Now we need to state non-permissible values. Now we have to be really careful in division questions. We have to check all denominators. So when we check for non-permissible values, we have to check here. That's a denominator. This was a denominator. And this now is a denominator. So there's 3 places we have to check. We have to check both original denominators and the new denominator because we inverted. Okay, so let's talk about the non-permissible values. When you just have a number in the denominator like 5, well, there's no x there. We're only looking for non-permissible values of letters, so there's nothing there. This guy is going to give us the non-permissible value that 2x cannot equal 0. Divide both sides by 2, x cannot equal 0. So that one gives us a 0. Then I would go down for this guy, I would go down to the fully factored step. Again, we don't have to worry about the 5 because it's a number. And so this guy's going to give us x minus 3 cannot equal 0. Add 3 to both sides. X cannot equal 3. So those are going to be the 2 non-permissible values we add in at the bottom as our proviso that all our work is valid as long as x doesn't equal 0 and x doesn't equal 3. Okay, not a whole bunch to cancel here. You can see that the entire bracket of x minus 3 can cancel here and here. No other common factors or anything. And so we just multiply and we get the top numbers to be 2x and the bottom number to just be 25. And then we slip in and say comma, as long as x doesn't equal 0 and x doesn't equal 3. Okay. Probably only one more question because this is getting a little bit long, but this is tough stuff. I was asked to do a simplification question. So let me make up something wild and wacky simplification wise. I think this might be what's asked for. And if not, then I can maybe do one more question. So the instructions are going to be very similar to what we've seen. Simplify and state the non-permissible values. And so it's going to look like this. 15x to the 3rd, y to the 4th, over 25 minus 25, x squared, y to the 5th. Let's do that one. I don't know if that was what was alluded to. I can look in a second, but I know that these questions sometimes cause us grief. So far, our process has been to factor, state non-permissible values, and then simplify. There is no factoring here. And there is no factoring here because there's no adding and subtracting. They're all multiplied. So this is what we would consider an exponential question from years past, where we're just going to have to go to the non-permissible stage, first of all, and then the simplification stage. There's no factoring. So we're going to go to the denominator. And since everything's multiplied together, we're going to be looking at the x for a non-permissible value and the y for non-permissible value. So we have x squared cannot equal 0. That means x can't equal 0. And we have y to the 5th can't equal 0. And so that means y can't equal 0 because you just take the 5th root, it's 0. So those are our non-permissible values. Now we try to simplify top to bottom. So what we're looking for is something we can divide into each part of the expression to get rid of and reduce it. So the 15 and the 25, they both have a common factor of 5. So I could reduce the 15 to a 3, and I could reduce the 25 to a 5. We'll just leave the negative sitting there. So on our next step, we'll have a 3 on the top and a -5 on the bottom. For the x's, you might remember that when you're dividing them, you can subtract the exponents and or you can just divide by x squared. So x squared divides, and this becomes x to the first because you subtract the exponent. So you get x to the first up top. Now the y to the fourth and the y to the fifth, common is y to the fourth. So you divide y to the fourth, this kind of goes away. This becomes y to the first on the bottom. So the way we would write this final answer, usually those negatives kind of just tuck out front. So our answer would be negative and then 3x, whoops, sorry about that, over 5y. X cannot equal 0, y cannot equal 0. So that would be our full answer. Okay, so let me pause the recording and chat with the students that are here.